Yeah, so when I started at Uber, actually, I want to kind of give you a glimpse of how the old Android code base was back in the day. So we had this one rider app that a lot of people contributed to, and everything was good until we also wanted to write a driver app. So when we wanted to write the driver app, a lot of things became apparent. We had a lot of shared code that we wanted to use from the rider app because we didn't want to like redo the same stuff again, which meant that we wanted to like share code between multiple apps. So we thought it would be a good idea to actually extract some common bits out into a library, and we decided to put that in a separate repository called and.library. And we did this via Maven coordinates. We set up like an Artifactory instance, and every time we would make changes to a library that both different apps would depend on, we would cut a new version that rider and driver would consume in the build.gradle file. And that was kind of good for a while. But at some point, what happened was we wanted to build even more apps, like the Eats app or some of the Fleet app or something like that. And as we started going down the path of building more apps, it became obvious that having just one library means that there's a lot of leakage of concerns and like patterns that should not have actually be used that is getting leaked into this common library. So we decided to actually split that further down into like core components. We should make it a little easier for people who come into the code base to be like, okay, this component deals just with UI or networking. We'll keep it that way to make sure that they have single responsibility. And all of these different components were in different repositories as well. And we would version them and would consume them similar to how we were consuming the library artifact. What happened was, once this kind of became like a practice, developers started to create a lot of different repositories. You would think, like, what are the repositories would people have? Like, sometimes you would want to build like a feature as a separate repository. One example is like the help feature. For example, if you go to the rider app, you can see like your previous trips, and you can go through all the different trips you've been and look at your stats. This kind of feature is also useful on the driver side of things if they want to go look at their previous trips. So we decided to kind of like build a few features in different repositories. So this led to a few issues as we had a lot of different repositories. The most obvious one was that, so there are actually, a lot of good things as well that I wanted to mention, there was clear ownership in these modules because a small module, a small repository did one thing really well, and that was great. And we also had like less toe stepping because you didn't have to really coordinate with other teams to figure out like what you were going to build out, and you could kind of like figure out how to integrate things later on, and things kind of got together in that main app. And a lot of different, and it's better for performance because your tools like the Android Studio, Gradle, and your builds are really good and pretty fast. And this is like really good for a long time. But there were also some issues that we had with this. They were like architectural silos. So sometimes what we would find was teams would build a feature using a different version of a framework. Some teams would use Dagger 1, some teams would use Dagger 2. And when we finally wanted to like integrate things, it would get really messy. And sometimes what would also happen is like, since teams really don't know all the different repos out there, they may not actually want to like reuse code. It actually ended up having the opposite effect, and people started building stuff in their own repo because it was like a lot faster to do it that way. And one thing we did do at this point though is that we had like a common check style across all the repos, so at least the code style was the same. And we had some tooling that we built with Gradle plugins to ensure that all the different repositories got the same check style. But it didn't really prevent design patterns from being deviated in different repositories. And the other problem was, there's a duplication of effort because sometimes you would not have discoverability of different features. And the other problem was for us as a tooling team, it was very hard for keeping things up to date because we would have sometimes like a Gradle update would be like a week of just going to all these repositories, pumping these dependencies, and making sure that everyone is up to date. And this does not even cover like the library. So let's say if some major update came out to like the experimentation or the UI library, no one would pick that up immediately. So it's kind of the responsibility of different feature teams to kind of adopt them at their own pace. But this still create problems when there are dependency updates that are kind of like not compatible at the app level. So that actually had a lot of really problematic consequences. One of them was that if you had to make a breaking change in a library A that a bunch of different libraries depended on, you would have to go change every single repository that depended on you and make sure that they were up to date and then bump it in the app repo. So this kind of slows everyone down because it's a lot of work. So you want to actually, ideally want to make a change once and kind of get done with it. But imagine things like support library updates. These were especially painful because even though the support library says it's a minor version bump, they typically break APIs. We actually had to like spend a bunch of time trying to figure out how to do support library bumps. And back in the day, I think it took us maybe, I think 3 months at some point to do like a support library bump, just because there was like too many different repositories on different versions of support library that we had to make compatible. And so to kind of solve this problem, we thought, what are the different approaches possible? So one approach where a lot of companies are taking was doing a monorepository, but we weren't really ready for it at that time. So we thought maybe we could do something simpler. So we kind of built this tool called Omega, which essentially is sort of like a virtual monorepo. What it did was it would check out the different repositories at the version they were basically cut the artifact at, and then it would bump the dependency, and it will try to like rerun all the build and test steps. So it's sort of like a virtual repo because everything would happen on CI, and you would get feedback on your change that, hey, you broke maybe a few libraries because of this bump, so please go and like fix them and bump it along with your change. This was still not really efficient because even though it prevented the dependencies from getting out of sync, what it didn't prevent was the fatigue of people going to multiple repositories to make these changes. So it was still a frustrating experience for developers. And as a result, a lot of our developers were having problems, basically doing their job effectively, and the efficiency of developers decreased. So then we thought, okay, so maybe monorepo may not be such a bad idea after all. So we started looking at how we could basically kind of adopt that pattern at Uber. Right, so we wanted to see if we could migrate to monolithic repositories to solve some of these pain points. And a lot of big companies have done this so far, like Facebook, Google, at a very large scale. So we wanted to kind of learn from their experience of like how it actually did this process. So this is one quote that I really admire because there's one of my favorite books by Alexander Dumas called The Three Musketeers. It's called One for All and All for One. So what this means in essence is one for all is essentially a way for one place to find all code, and all for one is like everyone really responsible for making sure that the code base is healthy and maintainable, and they're all focused on just making that one thing better rather than making sure that 100 repositories are basically kept up to date. So taking that motivating factor into mind, let's see how this evaluation into monorepo kind of took place at Uber. That's it, we're done, basically. It's usually never that simple. So I wish it was as simple as evolving a Pokemon, but it's not. So we saw a lot of companies doing monorepos out in the wild, but no one really told us like, hey, this is how you would like do the whole process end to end. Like, what are the things that you need to consider to make sure that you don't shoot yourself in the foot while you're doing this, right? So we just looked at the end state. We didn't really know what the journey was. So we kind of wanted to share that with you guys today. So usually it's not that simple. So a big question that we have to ask ourselves is, will things scale whenever you do things like a monolith? Because as you know, it's a really big thing, right? So it can be really complex. All your tools that you're used to so far may not really work with it. So we had to ask us a lot of questions for ourselves. First thing that we ask ourselves is, will VCS like Git or Mercurial scale? Right? So for us, we were using Git at the time, and we still use Git actually. Things to consider for us was like, how big will the repo get if you made it a monorepo? Because if you're doing CI builds and you're checking out this repo on your machines, you don't want it to be like really big so it can slow your builds down. At that point, we didn't have too many binaries in our code base, and we were aggressively like pruning binaries that were already checked in. So this is not really a problem. The other thing that is kind of how Git scales is by the number of files in the repository. So if you have like more files, your operations like git status or git ls take more time than if you have less number of files. So we wanted to kind of figure out if the number of files we had at that time would be a problem, and it is fortunately not. And even till today, it's performing at a decent level of performance. So we were like, okay, it's probably okay to like go through with this thing. And we found that Git would scale, so we were like, okay, that's the first thing to like check off the list. The next thing we had to do, which is really important, which is the reason why we couldn't pursue it before, was to check if the builds would scale. So this is one of the reasons why we didn't do it before, was because the Gradle tooling at that point of time, when we considered the switch, was still very old. Like we was like maybe 2.0.0 at that point of time, and it was really slow to like build even more than like 5 to 10 modules. So if you consider like 100 repositories coming in as modules, it would be like really, really slow. So we did prototype with Gradle. It just took us maybe like half an hour to 1 hour just to build a single app, and that was definitely not like a feasible solution like for a day-to-day basis. So we had to develop some new tooling. So we started looking at other build systems that Facebook and Google used. We kind of chose Puck because it was like a little bit more mobile focused. And we wrote a plugin called OKBug that kind of takes the existing Gradle configuration and makes bug files out of it. So we don't have to like do the whole migration through hand. And so we also wanted to make sure that the build system considered that only the changes that you make to the code, those exact changes get built. So what this means is if someone's working on, say, feature A, when the CI build or local build kicks off, it should not really build an unrelated part of code. So Buck actually satisfied this criteria for us, and this kind of meant that we could still kind of keep builds fast because most of the changes would happen at the feature level and not as much at the foundational level. And so breakage in one part of code, for example, will not affect someone else. So this is a good characteristic to have in a build system. So we kind of like figured that part out as well. Then we also wanted to see if other development tools like your IDE, any other like desktop tooling that you may rely on, like the visual Git editors or something like that, would scale. There are some tools that we would actually find that would not scale really well. Like Android Studio was one of them at that point of time. So we decided to use IntelliJ instead. And we had to forego some features like the Git GUI tools, basically like source tree or something, would not be like super optimized for like monorepos. So we had to like forego a few of them, but it was still not as bad. But we also, another problem that we had to solve as part of this was if you have like a big repository, a lot of developers can check in code on a daily basis, which means that you can see pretty much like 10, 20 commits coming in on an hourly basis at that point of time. And which means that there's very easy chance for them to like merge conflict, or if the changes they made can break someone else's tests. So we had to have a system to make sure that they didn't break master at any point of time, because if master is broken, people won't be able to build their code, and that's actually not good for anyone. So we had to build some tooling for this as well, and I'll talk about it a bit later. But this is kind of the things that we had to consider as well. And one of the good things that we had so far was that Uber's iOS DevX team actually already did a migration, and there's a really good blog post they put out about this. So we did have some people who are experienced with this process, and we learned a ton from them to make sure that we don't do the same mistakes again. And we also kind of like reused a bit of their tooling along the process. So before we like did the actual monorepo, we wanted to prove out our ideas would actually work on like a smaller scale. So we set up a small monorepo. It's not really a small monorepo as much, but we were rewriting the rider app last year at that point of time, so we thought it's a good test bed for us to actually try out our tooling with lower risk than making like everyone jump into the monorepo. So we put our tools in the new rider app repository, and we're like, this is very insanely modularized already because of our architecture. There's a talk that Brian gave yesterday about it. You should check it out. So we were like, we had about 130 modules at that point of time. And if you look at all the benchmarks that the Android Gradle tooling team publishes for the plugin, it's basically our exact same project. So I kind of basically removed all the code base and just obfuscated all the names of the project and gave that to them as like a skeleton project. And that was kind of helpful for like scaling their tools as well. So we took that small repository, built our tooling, and to make sure that we ironed out any issues with either CI or like the IDE. And it was really helpful to do like a smooth migration at the end. And the one thing we also wanted to consider was to not rewrite Git history, because it is extremely important for things like crashes, for example, if you want to find who had the crash and like where we can blame that in the Git history. And also just in terms of being able to like search and figure out like who's responsible for this part of code. So we had to take that into consideration as well. So we had to take something like all these repositories with their different Git folders and basically merge them into something like this. And there are tools out there that do this for you. I linked out this one, actually. We didn't use the exact same one, but it's very similar in approach. What it does is it takes like a small config file that says, give me all your repositories, and it'll put them in subfolders. So you don't lose any of your Git SHAs, and you can still do git log. It'll be exactly the same, and it'll create like a merge commit at the very top saying this is like the monorepo commit. So that was like extremely helpful as well. So we could do that without changing any of the Git history and like having to deal with like release tags and things like that. So once we kind of figured out all these like edge cases and tooling issues that we had to like iron out, we were like going to snapshot our repositories regularly. So we did this by running that script on a daily basis, and we got all our 100 repositories in one place. And then we would actually build the whole thing. And this is like the most tense part of my life in those few months when we were migrating, because we would never know what would break, and we still had to go fix these things. So whenever something would break, like someone breaks an API change, made a breaking API change, we would just be like, we either fix it today or we just delay the inevitable and we'll have to fix it later anyway. So that was not that fun. But we try to keep the time where we had this like hybrid state as minimum as possible to like prevent this. So in order to help us do that, we actually again built more tooling. So what we did was in the individual repositories, we use a tool called JAPI CMP. It's like an open source project. What it does is it takes a jar and then you can give it another jar/AR, and it'll kind of spit out like an ABI format that basically says, this is my public API of this version. So if someone made a change that actually breaks the API compared to a previous version, we would comment on the change on the code review tool and say, you're breaking this stuff, please don't do that because it's just going to cause more misery for us later on. So that kind of helped as well to make sure that we didn't have many of these breakages and we could kind of delay these kind of like API breaking migrations to a state after we did the monorepo. And to help with the dependencies, what we did was in all our Gradle files, whenever we refer to like an artifact, we replace that with something like a dependencies or Gradle file. It's a pretty common format where you have a top level dependencies Gradle file and you could have like a map that says, oh, my butter knife version is at X. And we would replace all the constant strings with that variable. And we would make sure that all the different repositories basically had the exact same variable. So when we kind of brought everything together, that variable names would match, and we would have to like figure out what versions they were at, and we could kind of get all the versions in sync as well. So that helped a lot by making sure we could refactor these things early on. And by detecting breaking versions early, we were able to like make the later on migration a lot more smooth. Then we have to talk a little bit about the rollout. So once you kind of figured out that, okay, we have the snapshots building, we have everything we building and fixing every day, we had to do a code freeze at some point because we couldn't like obviously chase these changes. So we froze over a weekend, just 2 days, where people don't usually commit stuff on the weekend anyway. So, but we wanted to keep the time in between commits that people were able to commit code as minimal as possible to like stop disrupting their workflows. So we took the time, basically make sure all our builds ran, all the build caches and everything were warmed up, and then we roll it out on a Monday. But there's a lot of stuff that we had to do even on a Monday. So one thing we had to do was make sure that we deleted all the old code. Otherwise, we would have people coming in and saying, hey, why is my build not building? I just did this stuff, but my diff is not like working. So we deleted all the code. Well, it's not often that you get a chance to do that in your company, but it was really satisfying to like just get to remove RF, everything, except that one monorepo. So we deleted all the code. We put a README in all the repositories saying that, hey, just go look at the documentation in the monorepo. And there's like a ton of documentation we had to write, like, because not many people were in the mini monorepo, so they didn't know how the new tools worked. So we had to make sure that everyone knew what the new process looks like. And we had to also set up some support channels and make sure that people were not trying to build with Gradle again, so, because that would definitely be really slow. So we had to basically set those like support channels up as well. And after that, I want to give you a quick overview of some of the migration stats. Of course, like these are like slightly out of date because this is like back when we actually did the migration and not today. But we had about, I think, 75,000 files. So we kind of deleted a bunch after we migrated because we want to keep Git performant. And this is at a scale, for example, one of the easiest things we could do was like delete all the Gradle.properties files on like thousands of modules that we had. Right? So that would basically cut a lot of files immediately. And there was like a bunch of Git ignores in every project that we could delete and just make like one at the top. So we had to do a bunch of stuff after migration as well to make sure our tools were performing. We had about 50K or 45K commits. It's not that much, actually. If you look at the scale of Google or Facebook, they have way too many commits coming in per day. But this, at that time, was still a lot for us. We had, I think, 800 diffs that we opened for migration. Diffs is like patches that we had to open to like unbreak changes when people were making breaking API changes. And that just ensured that everything was still building. And this is all done by us in a period of, I think, 2 to 3 months. And we have, I think, 350 megs of the repo size. When we migrated, we were aggressively pruning to make sure that the initial checkout was not really slow. It's gotten a little bit bigger. It's about 500 megs or something today, but it's still not as huge. Compared to the iOS repo, I think they have like a lot more binary artifacts in them. And if you had about 680 Gradle modules, what's the biggest number of modules you probably guess? I want to just like do a quick show of hands. How many of you have like 100 modules or something? 50. Not the Uber guys. 10. Okay. 25. Okay. So if you work with a lot of Gradle modules, of course your builds will be really slow. We have about 1,000 plus today, and it's constantly growing. But we've been actually able to scale really well. Like with our stack, like there's still a bunch to do in terms of like making things more incremental, more performant with like Gradle and stuff like that. But we still were able to scale even after 1,000 plus Gradle modules. I don't know if there's many people who use Gradle at this scale in mobile at this point. Maybe they do for backend, but on Android it's pretty uncommon. So yeah, we were still able to like scale really well. And I want to also talk a little bit about how it impacted our developers directly. Right? So we did all this work, so how did it pay off, or did it really go wrong? So we did a survey before and after as well to kind of measure sentiment of developers. A lot more people were happier because they didn't have to go through like the stuff that they used to before. But one of the big things was that having one repository meant that everything was in one place, super easy to find. Discoverability was really good. If you were looking for like a utils class or some network something, you could just like go to your IDE and you can basically say, find this class, and you would basically find it immediately. Right? And you could go refactor it immediately as well. You don't have to like go make a change in another repo, cut a new version, consume it. So that was easy. People who are working on platform level libraries had a much easier time migrating stuff as well, because if you had to make a breaking API change, you would just make like one diff, and that would basically solve the problem. And it's easy to set up and onboard new folks as well, because we could just tell, hey, just clone this one repo, don't have to like bother about anything else, right? Otherwise, you'd have like a big wiki. We had a mono wiki, I think, with all the repos you should care about, and maybe some more will come and add it later on. So this is a lot easier than doing that. And one version, so everything is at head, so no more dependency hell. It's very hard to like state how important this is. Not having to worrying about like versioning and like different compatibilities between different apps was like a huge productivity gain for us. Whenever someone bumps something, they are responsible or on the hook for fixing it, which means that what happens is people stop breaking APIs as often. They start like adopting better coding practices or like design patterns to like just augment the API with like a new entry point instead of like breaking the existing one and deprecate it more gracefully. So that helped actually in terms of both the code culture as well as not having to worry about like different versions. And one change set, so I already mentioned this, like if you had to actually break something, you could do it, and you could do it like in one go. So I think support library update after the monorepo was 3 days or something crazy like that instead of 3 months. So it's a huge difference compared to before. And we also had faster builds because of a new build system. It's like a nice side effect. And we also had just one CI job. So we kind of went overboard with this like one everything. So we set up like one wiki, one CI job, one repo, one IDE, everything one. Yeah, so we had one CI job and one build system, and that helped a lot in terms of build speeds. This is the cool stuff. So like always up to date. We didn't have to worry about getting people up to date on different versions of the tools. So as a tooling team, we were super effective. So like upgrading Robo Electric or support library is another example, but also upgrading like Gradle or like Bach or whatever else. Like it's just one commit. If you break something, you'll know immediately and you can fix it. And people don't ever fall behind. So any of the improvements we had to do would be like very easy to roll out. As an example, we also have a open source project called Nullaway, which is like a compile time null checker for Java code. We haven't like looked into Kotlin as much yet, but if you still use Java code, it's something you should check out. So we wanted to prevent NPEs in the code base. So we rolled out Nullaway in like one commit, and we were like, okay, let's basically suppress warnings, but fix it whenever we can. And then we kind of like were able to do like a very nice rollout of like a new static analysis framework. And so the static analysis team, we had like a separate team for that, is also like much more effective this way. This is the feature that I talked to you a little bit about. Keeping master green is really hard when you have like tons of developers checking in code, So we also had to ensure that they wouldn't merge conflict as much and don't step on each other when they're making code changes. So we made a system called submit queue, which is essentially like and I think of it like a queue where you would submit your change to merge to the master, and the system would essentially put you in this queue, and it'll kind of make sure that if someone's ahead of the queue that's already building, if you're going to merge conflict with them once they land, it's going to reject you straight away. So you don't have to waste time trying to figure that out. And also what it does is it kind of builds your change with others ahead of you in the queue in different combinations. So we had like 4 changes, for example, currently building, and the 5th one comes in, it'll kind of test different combinations to make sure you as a change are actually green with all the different possible combinations. So this ensured that we could actually merge your change in the same amount of time as like a regular CI build, but we could actually have like a long queue ahead of you. And we, of course, like optimized the algorithm quite a bit, and we are planning to open source this, but it's not ready yet. But this is something, I think there's like some implementations of this out in the wild, but I don't know if they're as efficient as this one. But this is something that you definitely need to have if you are going to do like a monorepo with a lot of different commits coming in. I think we process about 30 to 40 diffs on an hourly basis. So you could think about it like 1 every 2 minutes or 2 every 1 minute, something like that. So yeah, you would see it would succeed, and only then it would actually merge onto master. So this is like really important to make sure the master was always clean. So once we did this, we never had a master red failure again. It's very rare. It only happens if there's a flaky test or if there is like some infrastructure failure. But typically, code change-wise, we're always like covered. So this means that you can be really confident that you check out the code, that you can actually cut a release, or you can build and not have to worry about like weird issues with your setup, and it will just work. So that is like a huge thing not to handle on a day-to-day basis for us as a tooling team. And there are definitely downsides. I mean, of course, like if you're operating at this scale, not everything can be like perfect. So one of the issues was like, we also had to like do all these right tooling considerations beforehand, which means that we need to have people kind of like maintaining the system a little bit at this scale. And without the infrastructure bits like the build cache or like the right build system, the experience can be a little suboptimal. So that's something definitely to keep in mind. And definitely the journey is not over yet. Some of the issues essentially we have on the tooling side still are like better IDE support. This is not like a problem of Monorepo, more that the side effect of the build system you're using. There's not great support for IntelliJ integration as much as Android Studio has in terms of all the network monitoring tools and like constraint layout. So we're kind of working to get those ported over to the bug build system with IntelliJ. It's kind of a work in progress. But also, like when you have a lot of different projects, your IntelliJ indexing can slow down. So there are some hacks that we had to do to ensure that when you're working on a particular module, you just work on that module, and everything else is kind of like a library that's pre-built. So it kind of keeps your indexing fast. And we're also looking into distributed builds. Basically, when you have a lot of modules locally, I mean, if you have a MacBook at some point, they're not really releasing good MacBooks anymore, to be honest. So at some point, it's going to slow down if you have like a lot of modules and you're building it locally. So we either have to like use Linux machines, or we could do something where we could send these builds to like a remote cluster somewhere and just ask it to build it. And the build system we're using actually is like kind of prototyping these things right now, and we're working to figure out if that makes sense for us. And also, other thing that we're planning to do is like cleaning up dependencies. When you have a large code base, what can happen is it's very easy to forget that you're not using something and you still depend on it, which means that even though you're not actually using it, sometimes we end up having to build artifact A before we can build you. So we want to build some tooling to actually automatically detect these kind of like over dependencies and basically clean them up automatically for you. And we hope to actually open source this. Very based on Gradle, so I don't think it's specific to us, but definitely something that we want to also open source. And also dead code. So this is another big problem we have. Like when you have a big code base, one thing we did was we disabled a whole bunch of tests when we did the migration, and we still haven't enabled a bunch of them so far. So what happens is if you don't run these tests, we're still building them on every build, and we're just wasting time. And people who actually own the tests don't want to fix them. So we just need to find out a way to like delete them automatically on like a day-to-day basis. So a lot of code can get accumulated, especially not just test code, but also like regularly feature code, or maybe you have an experiment flag that you are experimenting with, but then this part of code was actually never deleted. It can be a lot more problematic in a monorepo because that small piece of code actually affects everyone else's build, not just your own build. If you're in a small repo, it's a lot easier because you're not really like bothering someone else. So we need to build some extra tooling to like detect and delete them. So one idea that we're pursuing is we're looking at the ProGuard APK, and we're figuring out what bits were actually in the APK, and then kind of mapping that back to our source code and deleting stuff automatically that we're actually not using. So that's kind of like still in investigation progress, but there's still a lot of cool stuff that we can do to like make the experience like optimal. And I think that's about all the stuff I have on the Monorepo, and I'll be taking questions.